Homework 25, question 1. In part A, we've got some information about a ball that's projected vertically upward. I've drawn it as a diagram, and I'll talk through the key bits of information. The ball is projected vertically upward with speed u. Gravity, however, will be acting downward, so we're going to need to do a sign change here. It's projected upwards from point A, which is 1.5 meters above the ground, and then it travels to its greatest height a further 25.6 meters above A. Now I've drawn the diagram with a slight curve. There is no horizontal movement, it's only vertical, but this stops the lines from overlapping. We need to use SUVAT, and we need to take the key bits of information. And in part A, I'm only going to be looking at the journey from point A to its maximum point. This then covers a distance of 25.6 meters. I'm choosing up to be my positive direction, so I know it goes at speed u, and that is what I'm trying to find. When it reaches its maximum point, its velocity is 0, which is v. Acceleration under gravity is 9.8, but this is going downward, so I need to use a negative. And time has no place in my question, so I mark that with an x. The formula that connects up s, u, v and a is v squared equals u squared plus 2as. So if I put this information in, I get 0 is equal to u squared minus 2 times 9.8 times 25.6. With a bit of rearrangement, 501.76 is equal to u squared, and so u is equal to 22.4 meters per second as required. In part B, we're now trying to find t to 2 decimal places. I once again need to start with some SUVAT problems, but this time I'm using the whole journey rather than just up to its maximum point, so I need to reset what I'm using. My value for s is the 1.5 going down. Now I'm going to once again use up as my positive direction, so s is minus 1.5. I can use the value of u that we found earlier at 22.4. V is the value of the velocity as I hit the ground. I don't know what that is, and it doesn't have any part in my question. A is still 9.8, but that's going downwards, and if I've chosen up to be positive, that's minus 9.8, and t is what I'm trying to find. The formula that connects up s, u, a and t is s equals ut plus half at squared. And so if I fill in my values for that, move paper up, minus 1.5 is equal to 22.4 t minus 4.9 t squared. This is a quadratic equation. Rearrange it so it's set equal to 0. 4.9 t squared minus 22.4 t minus 1.5 equals 0. I can solve this on a calculator or with the formula. I wouldn't expect a question like this to factorize, and it doesn't. T is equal to 22.4 plus or minus square root of minus 22.4 all squared minus 4 times 4.9 times minus 1.5 all over 2 times 4.9. This gives me two solutions. The first one is t is equal to 4.64 to 2 decimal places. The second one is minus 0.07. But as t has to be greater than 0 to cover the forward part of the journey, t is equal to 4.64 seconds.